Here's a review of stereochemistry with molecules that have one chiral center or two. The one is very simple. Here I have a carbon with 4 different groups attached to it. I could put a mirror plane here and look at what the mirror reflection would look like. That would be the mirror image. If this were S with the H pointed to the back, which is priority number 4, this would be the R. And clearly these are non-superimposable. I cannot take this molecule up out of the plane and twist it and turn it in any way to get it to superimpose on this. So these are enantiomers, mirror images of each other. Non-superimposable mirror images. So now, if I have two chiral centers, it gets more complicated. So here's an example in which I have two identical groups on two adjacent carbons. And I could make this a mirror image of this molecule by simply putting the mirror plane here and doing like as I did above. Or I could simply reproduce the molecule and simply interswitch both of the stereocenters so that now the chlorines, instead of coming out, are going back. In doing so, I would change the designation to SS. So these are examples of RR to SS. These are enantiomers. There's nothing I can do to take this out of the plane and move it in here, rotate it, flip it to make it superimposable in here. Secondly, it does not have a mirror plane through here. For instance, if I were to rotate this bond right here so that this Cl is now up here and this methyl group is pointed down, you can see the Cl here is pointed out and the Cl here would be pointed back. So there's no mirror plane here, so in fact these are non-superimposable mirror images or enantiomers. But I could make another isomer out of this. RR, another variant, would be RS. All I did was copy and paste this here and change the R to an S by making the Cl going down. Now I'm going to make a mirror image of this, not by putting a mirror plane here, but simply duplicating the molecule and simply changing the R and S to S and R. And in doing so, again, question is, are these molecules identical? Can I take this molecule out of the plane and flip it so it aligns with this? And I think you can see that we could do that. I could just take this molecule over here and literally rotate it. And if I rotate it 180 degrees, this Cl is up here, rotated in the plane. And this Cl would be down here. An easier way to see that maybe is, does this molecule have a mirror plane in it directly? So if one looks at this bond here, if I were to rotate around this bond, so flip the Cl up to here, and this methyl group would be pointed down, yeah, I think you could see from that I'd have a Cl pointing out in both cases, the methyl groups in the plane coming down, so there's a mirror plane here. So that means these molecules are identical, they're superimposable on each other, they're not mirror images of each other. So this was an example of a meso compound. Going from RR to RS, though, these would be example of diastereomers. They're not mirror images of each other. If they were, the RR would have gone to SS. So, but they're different from each other. They're non-superimposable, so we would call those diastereomers. The same thing can be done with cyclic molecules, and it's actually a little bit easier sometimes. So here's a molecule that's an RR, and the question is, this is its mirror image. What I did is simply, I took this molecule and cloned it over here and simply flipped the methyl group, so now this is pointing back and this is pointing out. So this would be S and S. We started with R and R. In addition, actually, if you look at it, it looks like if I did put a mirror here, this would be the mirror reflection, which would be the mirror image. So is this molecule superimposable on this? It turns out not. I can take this molecule and put it out of the plane. If I flip the plane, you would see that this then would be pointing down here, and this, when I flipped it, would be pointing up. These are non-superimposable. So they truly are, they're mirror images, so they're enantiomers. There's no plane here as denoted by the X. But now here's an example. I could make, instead of the RR, I'll make the RS. This was an example of a diastereomer. Now both the methyl groups are coming out of the plane. As you can see right away here, there's a plane of symmetry here. Now if I were to draw the mirror image of this, again, I'm not going to put a mirror plane here, but I'm just going to flip the designations. RS to now SR. These methyl groups are pointing down. I think you can say if I take this molecule out of the plane, the board, and bring it over here and simply flip it over, it would align. So they're identical molecules, and again, these are meso compounds. And of course, this is evident because I have a plane of symmetry here. So that which is on the left is the mirror reflection of that which is on the right in both cases. But what if the molecule is a little bit more complicated? So here I have two identical substituents that are just, here they're separated by no carbons, and here they're separated by one. Here I put a chloro, and here is a bromo. Well, again, if I make the mirror image of this, simply by changing where the chlorine and the bromine now are going back into the plane, I would have to change RR to SS. These are clearly non-superimposable, and there is no mirror plane across this bond. But I could go make the RR, I could make an RS. I would simply change the stereochemistry here. And in doing so, if I try rotating around this bond, again, if I do, the chlorine would be out of the plane, and the bromine would be out of the plane pointing toward you, and clearly there's no plane symmetry because the attachments are dissimilar. So there's no inherent symmetry in this molecule. So the RR and SS here enantiomers, so would be the RS and the SR. They're different. And of course, the RR to the RS would be a case of diastereomers. Here's another example with a cyclic molecule. I think you can see readily here. There's no mirror plane here. So this must be an enantiomer of this. And that's either drawn by simply changing the wedges going out, coming in, going back into the plane, or I could literally put the mirror plane here. These are not superimposable. Whereas this molecule, the RS form, clearly is because I have a mirror plane here. Again, this hopefully gives you a summary understanding of chiral molecules and stereochemistry.